All right, so now we have a potato. It's being launched vertically upward with an initial velocity of 105 feet per second from a potato gun at the top of an 80-foot tall building. Now, in the very strictest sense, the way this is written, if you approach it from a physics perspective, it goes up and then it comes back to the top of the building because you said you did it vertically upward. So in math land, we don't pay attention to the horizontal change in position. All we model here is the vertical change in position. So, like, it actually does arc off the building. So all it is modeling here is the height. There's some other function that would model how far the distance from the building or the horizontal distance. Yes, yes, math land, not physics land. So we have our function here, our position S of t equals negative 16t squared. Negative 16 is because that's half of gravity, which is 32 feet per second squared. Then 105, well, that's our initial velocity. And 80, that's the height of the building. So when this thing starts, it's 80 feet in the air and then goes up some and then down and splat. Okay, so the velocity of the potato at 0.5 seconds and at 5.5 seconds is. And then the speed at those same things. So we're going to find our velocity function. So S prime of t, which is the same as v of t, is negative 16 is a constant multiple. So we pull it out and then we write parentheses. Otherwise, it's like, is it a multiplication or is it a decimal? And in my writing with no lines, it is confusing. So parentheses, and then the derivative of t squared, powered down, 2t to the 2 minus 1, which is just 1. So I'm going to be lazy and just delete it there. Plus 105, that is t to the first. So that would technically come down as 1 times t to the 1 minus 1, which is 0. T to the 0 is 1. 1 times 1 is 1. Times 105 is 105. And then 80 is a constant flat line. So the derivative of 80 is 0. So I'll still write the 0 for the placeholder there. But our velocity function formula is negative 32t plus 105. So for every second, the acceleration is pulling down by 32 feet. But our initial velocity was up at 105. So that's what this is telling us. So now to answer those questions, we're just literally plug in the numbers, do the thing. So V of 0.5, that is negative 32 times half plus 105. Half of 32 is 16. 105 minus 16, 95 minus 6, 89. So that is 89 feet per second. And notice they actually wrote the units here. This is very much like screenshots straight out of WebWork, or at least past WebWork. I don't know if it'll be like this in current WebWork. So our speed at 0.5 seconds is the absolute value of 89, which is still 89 feet per second. And I mean, after a half a second, yeah, it's probably still going up. All right, now our velocity for 5.5 seconds. So negative 32 times 5.5 plus 105. So negative 176. So negative 76 and 5, negative 71. I know I did that in my head. Again, it's because I don't have a pretty calculator and I do way too much number crunching, like some Doku puzzles. So our speed at the 5.5 seconds is the absolute value of negative 71, which is positive 71 feet per second. So this was just the difference between velocity and speed using our velocity function. We don't typically make a speed function because mathematicians like hate absolute value like it's the plague because it's confusing to try to differentiate because it has a corner point. So there is a point where it's not differentiable, and if that point is in the middle of your like desired domain, then you got problem. But in physics, it has uses and meaning. All right. So we have the same potato, all the same numbers. But now our question is, while airborne, the height of the potato is increasing on the open interval blah and decreasing on the open interval blah. Okay, so when the height is increasing, which direction is it going? So my height is increasing, I'm going up. And then I get to my top point, and there's like this briefest microsecond of pause, and then gravity pulls it down. So the height is increasing when the velocity is positive, and then the velocity pauses at that top point, and then acceleration, gravity pulls it down. So our split point here is when is the velocity zero? So we're going to take our velocity function. Hold on. Which was negative 32t plus 105. And we are going to figure out where it changes direction. All right, so we know from before at 0.5, it's going up. And solving this like, so 0 equals negative 32t plus 105 minus 105, divide by the negative 32. And that is not a very pretty number. It's like 3 and change, I believe. Oh, excuse me. 105 divided by 32. So this is 3.28125. So that is how long it takes for the potato to go up before it starts coming down. So the potato is increasing. The position height is increasing from or on the open interval. So our starting point here, whenever we have these like real world math land, but there's like a reality being put in there, then we actually have to think about like, what does that reality mean? So when we start counting time, do we talk about negative time? Not in math. So our time starts at 0. Like when this function is actually modeling what's going on, we started at 0. And then we're clocking it. It goes up to 3 point. Sorry, that is not where it goes up to. At 3.28 seconds, it is at whatever its highest point is. And then after that, it's decreasing. So the decreasing will start at 3.28125, but then it goes, how long does it go? So then this is, we're asking, well, when does the potato hit the ground? Not when does it get back to 80, but when does it splat on the ground down below? Hopefully not hitting anyone. So we have a side quest. When does potato hit ground? So I want you to think, like, when does it hit the ground? When is asking us to find a time number. Hit the ground is giving us the position. So what is the position? And let me just check. See, it says the height of the potato in feet above the ground. So when it hits the ground, it's not above the ground anymore. It's on it. So that means our height there is 0. So when does the potato hit the ground? When the height, which is our position function, s of t, equals 0. So this is now 0 equals negative 16t squared plus 105t plus 80. And a question like this is not a pretty number. This is a pull out the quadratic formula, use your calculator, or use Desmos because this is not on a test. This will be on homework. But just to refresh your memories, the quadratic formula, and yes, this is just an excuse for me to sing, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I've also heard it done to the tune of Bad Romance, which was pretty interesting, but, you know, not out when I was a kid. I'm old. All right, so remember that a is on our squared term, b is on our linear variable, and c is our constant number. Now, the formula is written x because we're usually in math, we usually write things in terms of x. This particular quadratic, though, is in terms of t. So what we're actually going to solve for is t equals, and then this will be negative 105 plus or minus the square root of 105 squared minus 4 times a negative 16 times a positive 80 all over 2 times negative 16. Now, normally I try to clean things up a little, but 16 and 105 don't actually have any common factors because 16 is just a bunch of 2's and 105 has no 2's. So, is what it is. So we'll clean this up a little. Let's figure out what inside the root is. So 105 squared minus 4 times negative 16 times 80. So we get 16,145. I'm going to go ahead and square root that. So we have negative 105 plus or minus 127.062, blah, blah, blah. All over, this will be negative 32. So because this is a parabola that starts up in the air, goes up and comes back down, one of our points will be to the right of 0. The other point is going to be before. And in physics, that point actually has some meaning. It's the how far back do I have to walk, or how long back, which you then do other calculations to figure out how far back would you have to be to make the ball go in the same arc or the whatever. All right. So we want the positive number. This is where it hits the ground on the right. To get the positive, though, since we're dividing by a negative 32, we actually need to use the negative. So that gives us negative 232 something, and then we divide that. And our time number here is 7.25196, blah, 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 blah. So just 7.252, sure. So that is you probably want to copy more decimals for web work, but meh, that's good enough. So it increases until about 3.28 seconds. And then from that time until 7.25 seconds, it's decreasing. And then it's on the ground. And any of the function values past 7.252, we don't care what it does. In the context of this problem, those points don't exist, just like the points before where time equals 0 starts don't exist. Now, if we were like shooting off of a building on the edge of a cliff, then those negative numbers might actually have to have some, would have some meaning, because then it'd be like, how many feet below the level of the cliff does the potato go? But that is a more convoluted problem that math conveniently ignores. All right. So that was our potato. I'm going to stop it here because the next one, we've got two slides all about the same, but it's a new function.